we need to take the quiz and the first exam next week. All right? So what we got? What's going on today? Or did everybody just say Friday? We just gonna, nobody knows? Okay. Let's see. Well, let's give it a few more minutes and let's see how many people show up. It's only 12:01.
Can I ask you a question quick?
Yep.
Y'all gave us a quiz for our citation, and I just didn't know if we had a question because I didn't know how to do it. It says a ball is thrown horizontally from the roof of a building, 10.5 meters tall, and lands 9.5 meters from the base.
Yeah.
What was the ball's initial speed in meters per second? We got one like that. I didn't know if we had.
So let's talk about it. So let's go through the problem solving procedure.
Okay.
What are we looking for? Number one,
Initial speed.
initial speed. So initial speed, right? We normally indicate that as v sub naught, right?
And then it's in seconds.
So we're talking on the seconds level, right? Seconds. All right, so this time I guess we could draw a diagram, right? Might make it a little easier. Here's your building. All right, and you said what was coming off of it?
A ball is thrown.
A ball is thrown.
Horizontally.
Thrown horizontally. So I'm gonna draw my stick man on top of the building. And he's gonna throw the baseball horizontally. Right? So, and it says what? He threw it horizontally, and what happened?
It says the building 7.5 meters tall.
So here we have what? 7.5 meters. 7.5 meters tall.
And then the ball lands 9.5 meters from the base.
And then the ball lands 9.5 meters from the base. So we just draw, right?
That's all.
Right? Okay. So we know this distance right here, right? We know this distance right here. And we're trying to figure out the initial speed, right? So what we need to do now is figure out what? In order to calculate speed, if we have distance, what else do we need to calculate speed?
Oh,
Time.
Yeah.
Time, right? So when I throw something off of a building horizontally, that means that that's the same as me dropping. So the initial speed in the x direction, right, or in the horizontal direction, right? So we're taking these, we're breaking them up now, right? We're not talking about projectile motion, right? So in the horizontal direction, this is the distance, this is the speed. So we need to figure out the time to get this initial speed, right? So in this direction, right, if, like I was telling you, if I throw something horizontally, that's the same thing as me doing what? Dropping it, right? So that means that the initial speed in the y direction is what? 0. And so we know in the y direction, right, the constant, well that's step 4, right? So let's go to 4. Right? In the y direction, the what is the acceleration in the y direction? Which is what we call what? Gravity. All right? And so we're going to use the what? Equation. Constant acceleration equation. right? Only instead of X horizontal, we're gonna use what? Y, which represents what? Vertical. So that's what we need to understand, right? We're talking horizontal and vertical. Okay? So Y equals what? Y naught plus V0t plus 1/2 GT squared. Alright? So we just said what? So this is in the Y direction, so I should say VO in the Y. Right? So I just told you that what? When I throw something horizontally off, my VO in the Y is what? 0. And so the distance that is traveled before I threw it off is what? 0. So that leaves me with what? Y, which is this distance, I know this distance, is equal to what? 1/2 GT squared. Now I can do what? Well, not just yet, but I could solve for T, right? So T is going to equal to what? 2Y over G square root. Everybody following me on that? So I multiply both sides by 2 to get rid of this 1/2, and it popped up 2Y. Then I divided both sides by G, so that'd be 2Y divided by G, and I'm left with T squared equals 2Y over G. So square root of both sides, T equals square root of 2Y over G. Got an answer? I hope I recorded all of that. Yes, indeed. 2 times what? 2, so it's T equals what? Square root of 2 times 7.5 meters divided by 9.8 meters per second squared.
I got 1.24.
1.24 what? Seconds. That's reasonable, right? 7.5, what did they say? 7.5 meter building. I would imagine that's like what? I don't know. Maybe about what? 20 feet or something? Something like that, I don't know. All right, but anyway, 1.24 seconds, right? So now we have the time. So time is, I told y'all about time, right? Time applies on both Y and X at the same time. So whatever time I calculate on X, on Y, well, on Y here, I can use that same time for X. Everybody following me? So now I have the time and I have the distance, so I can calculate initial speed. So it's probably gonna be what? 1.24 seconds times, what is it? Distance, what is it? Distance, speed is distance over time. So 9.5 meters divided by 1.24 seconds. What'd you get?
7.7.
7.7 meters per second. 7.7 meters per second. That sounds reasonable. If you're throwing something, right? All right, so any more questions? Concerns or comments? So I'm giving y'all the opportunity to address any issues you may have before we get into next week and we start taking these tests, right? Let's talk about whatever issue you might have now. All right? So everybody solved all of the problems, and
I just wanted to say for the homework that you had extended that night, I did it, but it's still like, it doesn't change your grade once you do it. Like it still says 0. But it's because it says no credit for late work, because it doesn't say that it was extended, but I was still able to complete it, if that makes sense.
you said it says it was extended though. How else will I extend it other than change the date?
Because it says no credit for late work. But, like, I don't know.
Did you refresh?
Yeah, I'm gonna log in right now and see what it says.
All right, now. Yes, sir.
So if I'm correct, this quiz is over
Chapter 2.
it's all chapter 2.
Yeah. One-dimensional motion. So either free fall, which is that good problem. We just went over that problem because it did both. Free fall or horizontal motion,
Gotcha.
right? So the natural progression from here, right, is projectile motion, right? So what is the difference between projectile motion and the motion we have been studying so far?
One can speed up, like projectile, it can like constantly get faster and then slow down.
Well, no, we can do that. We can do that in this chapter, right? Because that's what happens when you drop something. What does it do? It starts at what? 0, and then it does what? Speed up. Okay, so that could very well happen in one-dimensional motion. But the difference with projectile motion, right, is that instead of motion in one direction, you have 2 directions. You have motion in 2 directions occurring at the same time. So if I have, just on common sense, y'all, just common sense, right? So let's say if, let's say this was a rocket launcher. Right here, this spot right here, launched rockets. And we took something and we blew a fan or something like that, right, in this direction and in this direction at the same time. Which direction do you think the rocket is gonna come out at? Yes, right? The rocket is gonna come in between those 2. That's projectile motion. So that is 2 sets of motion occurring at the same time. And so, if you notice, this looks like a what? Triangle. So that's why we're gonna get into Pythagorean theorem, sines, cosines, tangent, all of that trigonometry stuff you learned. We're gonna jump right back into that in chapter 3. But now I'm just explaining to you like how the progression happens, right? So we start off with units. That's so we can even understand how things move, right? Because the units we dealt with to begin with were units of length, units of speed, units of time, right? So now we talk about things actually moving in one dimension. And so we add another dimension, And we call that projectile motion because that's how things move in real life. Things move in real life, well, things move in real life in one dimension too, right? Free fall. If you fall off of a building, that's a free fall motion. You're gonna move in one dimension straight to the ground. And that's why it's likely, depending on how high the building is, you're gonna die. Or you're gonna hurt yourself. Right? Because you're coming down at 9.8 meters per second squared. Right? That means every second, your speed increases by 10 meters per second. So if I fall off a building and it takes me 5 seconds to hit the ground, right? By the time I hit the ground, I'm somewhere around 50 meters per second. So your speed is changing as you move down in one dimension. But with projectile, we're talking about what? Two speeds acting on the same object at the same time. Okay? So that's chapter 3, that's where we're going to introduce vectors. So we got a new type of mathematics. It's not really new, but it's not what y'all are accustomed to with just numbers and stuff, right? So we're going to start to move into what? X. So to describe something, we're going to start having X equals what? Let's say, well, we're still going to have numbers. I just thought about it. We're still going to have numbers and stuff, but let's say, anybody in here in the military? Nobody? Okay, well. So X is a position vector. So if I wanted to describe the position of something, right? The reason why I asked about the military is because a lot of times the military, when they describe or when they say, all right, well, I need directions somewhere, or I need to get to some spot, right? They may have to traverse like deserts, forests, whatever kind of terrain there may be. And so it's not like they can say, hey, go to this street and turn left and do this and do that, right? Can't do that. But what you can say is go this distance, these many miles, and when you get to the end of that, go in the Y direction, these many miles, right? That's how they describe, that's how they talk in coordinates, right? So when we describe a position vector, so say for instance, this is a position, right? Or this is a coordinate system, right? Coordinate system, everybody familiar with an X, Y coordinate system? Right? So if I want to describe a position right here, then I need two things, right? An X and a Y. I can't describe this position without an X and a Y. So, right? So imagine if this was headquarters, right? Home base or whatever, and your guy or whoever got lost in the bushes. These are all bushes, right? All this bushes. Can't nobody see nothing. Right? But all they can say is, oh, I remember I went these many miles north. That's what I'm gonna go back. That's what I'm calling back to the headquarters saying, hey, I'm lost in the bushes. I don't know where I'm at, but I remember I went 10 miles north and I went what? 5 miles east. So we describe that position vector as what? 10x plus 5y. Y'all following what we just did there? Right? So when we get in the helicopter and we go to rescue the lost person, instead of going 10 miles north and 5 miles east, what can I do? Yes, you're a smart man. Go straight there, which is shorter. saves me some time. And what do we call this right here? Hypotenuse of the triangle. Yes, sir. That's the hypotenuse of the triangle, right? And the triangle has x component of 10, has y component of 5. So, I guess we're gonna jump right into this next week since we don't have any more questions, concerns, or comments about chapter 2. Right?
So, your class on Monday, and then Wednesday is the quiz,
Yep.
and then Thursday is like the review,
Yeah, we can do that, yes.
and then Friday's like
Then the Friday we'll take, yep, chapters 1 and 2.
Oh, so the test is both chapters?
Yes, test is both chapters,
Okay.
cumulative.
Do you have all these videos posted already?
Yes. Yep, they all on the campus page. Yep. And like I said, we could do a review and we could post that too. So, but like I say, the review for me, y'all. The review is as good as you make it, right? Because I'm gonna come in here and I'm gonna say, hey, and ask me whatever y'all want to ask me, and let's talk about it. So whatever questions you got, that makes the review better. If you come with questions, as opposed to expecting me to come with a study guide to hand out or something, which is not the way I operate. But a lot of people around here do. So, but not me. All right? I'm putting it in your hands, saying, ask me the questions. Then we'll go over it and we'll record it and it'll be content. You know what I'm saying? You can go and access it, stop it, record it, whatever. I tried this last semester, but people just don't want to. Some people did it, right? Well, the people in my class generally do it. I tried to help some folks in another class, in physics 2, right? Because, some people find find it difficult to understand Dr. Zhao. Dr. Zhao has a thick accent.
Very good.
Yeah, so, sometimes it's a little challenging, even for physics majors, so it's not just y'all. But I tried to post problems, post from chapter, from physics 2, and nobody looked at them. So, no. But people generally look at my stuff, so I don't know. Well, stuff for this class. So yes, it would be up there, and I post them the same day. Every day I come and record. As soon as I get home, that's what I do. I just post it. Because I forget about it if I don't do it as soon as I get home.
And then I can go in the book and get problems from there to.
Oh yes, absolutely. Or Mr. Google Man, right? Mr. Google Man is a good one, Yeah, but like I said, generally, so that's another thing. That's why I don't give y'all problems like that one that you were talking about, right? Because I would never give you a problem like that on the exam. Because it's just a waste of time. It's not necessary to go that deep into it. So I would never give anything like that. Now, when we get to projectile motion, we're gonna be into that quadratic equation. Very well into that quadratic equation. But at this point, we shouldn't be talking about quadratic equation. Not yet. We ain't even did vectors yet. We ain't talking about Pythagorean theorem yet. Even though they ain't got nothing to do with Pythagorean theorem. But, like I say, generally we talk about that in chapter 3, the end of chapter 3 with projectile motion. So no more questions, no more concerns, no more comments, huh? You say what?
As of right now.
As of right now?
Something might pop up over the weekend.
Okay, well, yeah, I'm available, so you can always, I will be back on Monday, so we still got a day to But, you know, I was just about to say though, if we don't have any questions, y'all, then I'm just gonna, then maybe on Monday I can just start chapter 3. So what you saying? But see, I can't keep delaying, right? You know, but, you know, at some point we gotta move on. But yeah, but if you have some questions though, just pop them up at any time. Don't matter. But yeah, we might do chapter 3 on Monday, at least the slides. You know what I'm saying? So, continue to prepare yourself for chapter 2, right? And have some questions for me on Monday, right? And definitely have questions on Thursday, right?
But that's what we're 1 and 2, right?
Yes, that'll be a review for the exam on Friday.
Chapter 1 was just converting, right?
Yeah. Yep. So just conversions and mechanics or motion in one dimension, free fall or horizontal. Just those 3 things. So it'll probably be about 3 problems. Yeah, 3 of at the most 4, no more than 4. I'll probably do 4 just to make it easy for me.
Wednesday?
Friday
Oh, for the exam.
for the exam. So the quiz, you know, that's the first quiz was what, 3? Oh no, we had 5 on the first quiz. Yeah, this one will be probably like 3 or 2. Because each problem has probably multiple steps in it, right? So I give you like 2 or 3. No more than 3 on the quiz, no more than 4 on the exam. All right? All right, see y'all later. Have a good weekend.
You too.